Assalamualaikum and good day to my supervisor, Dr. Engineering Al-Hassan Salami Tijani, and my two panels, Dr. Azlin binti Muhammad Azmi and Associate Professor Dr. Aman Muhammad Ihsan bin Muhammad. My name is Cik Nur Zaimah binti Hashim, and today I would like to present my final year project 1 proposal regarding on numerical analysis of forced convection heat transfer of horizontal cylinder heat sink with perforated branch fins. Okay, first of all, I will explain about the project abstract of this study. This study is related with heat sink device where it is function as passive heat exchanger that absorbs heat generated by electronic components or chips. This project also focuses on determining the thermal performance of horizontal cylinder with different geometries of perforated branch fin under forced convections. Besides, the method that need to be used to accomplish this project are by using CATIA V5 and ANSYS software, where CATIA V5 is used to design 3D heatsink model, while ANSYS software is used to analyze the heat transfer characteristic. Next, I will briefly discuss on project background. In this era of rapid development, heat sinks are widely used in industry to give a better heat transfer within the electronics or mechanical device to keep the temperature at ideal levels. Extended surface design to increase heat transfer rate for a fixed surface temperature. In other studies also, they said that branching fins found to be more effective and had lower base temperature compared to the rectangular fins. The functions of extended surface are to increase the surface area and to make the heat sink more lightweight. Move on to the perforated fins. As studied by Pankage, the heat transfer rate for the perforation fins is best suited horizontal rectangular fin array. Besides, perforated fin with square perforation has shown a reduction in the fin temperature compared to the non-perforated. Higher heat rates were dissipated by increasing the number of perforations. In my best knowledge, there is no experimental study in open literature regarding on the effect of thermal performance that combining these two features, which are perforation branch fin attached to horizontal cylinder pin fin heat sink. Therefore, in the present study, the design that I will propose are going to be compared with conventional design, which is solid branch fin under forced convection. For literature review, this study seeks to investigate these three theories such as types of fin heat sink, material of pin fin heat sinks, and perforated fin of heat sink design. Okay, first we will look on type of fin heat sinks. As mentioned before, extended surfaces are usually used to dissipate the generated heat by computer chips in various applications. In previous study by Carla Palem, he stated that different types of fin heat sink have been proposed through several theoretical, experimental, and computer studies. He also said that branching fins have more effectiveness and efficiency compared to the rectangular fins. Second is material of pin fin heat sinks. Metals with various thermal conductivity are generally used to design an efficient heat sinks. This is because heat sink will functioning well when the material used has high thermal conductivity. Aluminium is one of the most common metal used to design an efficient heat sinks because it has high thermal conductivity with low cost and lightweight. As mentioned by Ibrahim, the studied fins were made from aluminium alloy due to it is inexpensive and has low density. The table below shows the thermophysical properties of air and aluminium alloy that will be used in this present study. The third one is perforated fins of heat sinks design. In figure 1, it shows that the result of previous study from Al-Damouk. This figure shows a comparison of surface temperature of the solid pin fin heat sink with 5 perforated pin fin. This figure also shows the temperature of the perforated pins are significantly cooler as indicated by the blue region color. Al-Damouk reveals that the pins with 5 perforations are having a 11% larger Nusselt number compared to the solid pin cases. After carried out the CFT simulation, the result shows that the rate of heat dissipation of perforated fins up to a certain number and size of perforation is often greater compared to the solid ones. According to Maji, the studies are about evaluate the heat transfer enhancement of the heat sink using linear and staggered perforated pin fins as shown in figure 2. Next, move on to the problem statement of this project. Computers and laptops are commonly used worldwide, and the use of microelectronics in system components tend to overheat and makes computer system failure that will cause the lagging of random access memory RAM due to lack of heat dissipation. The current heat sinks that are being used can be enhanced by changing the properties and characteristics of the current heat sinks, such as the material, porosity, shape, or perforation of the pin-fin heatsink. This research focused primarily on these three following objectives, which are: first, to develop a horizontal cylinder heatsink with different geometries of perforated branch fins; second, to compare the thermal performance between solid branch fins and different perforated shaped branch fins; and the third one is to evaluate the result of thermal performance between simulation and experimental data of previous research under forced convection. Okay, next I will explain about the scope and limitation of the project. The scope of work for this study is to design a 3D model of present heat sinks model by using CATIA V5 software. And it is need to create mesh geometry to run simulation by using ANSYS software, where it is also function to analyze heat transfer characteristic of horizontal cylinder with solid branch fin and different shape perforated branch fins. There are limited studies for this project, as students are not allowed to conduct any experiment at thermodynamics laboratory at UiTM Shah Alam, and the study can be accomplished by simulation only and only can be compared with the experimental data by previous researchers. Okay, so this is the flowchart for methodology of these studies, where it can be categorized into 4 phases, which are: the first one is research phase, which consists of gather data and information and generate design ideas. Second one is design phase, which consists of geometric modeling and model equation. The third one is simulation phase, which consists of mesh geometry and run simulation using ANSYS software. And last but not least, result and discussion phase, which compare the simulation with experiment data from previous research. So the first one is gather data and information. This task can be accomplished by refer to previous study, a specific topic journal, and also by using the textbook from the previous subject. It is because it will help to gain knowledge and understanding about all the parameters and equations required that need to be applied for present project. It is also help to understand the mechanism of heat transfer, thermal efficiency, and fin designs. Next, generate design ideas. According to the several studies, branch fin can be used in cooling system in different thermal system compared to plate fins. The temperature along the perforation fin was decreased efficiently compared to the solid fins. The reduction in fin temperature is possibly due to a higher rate of heat transfer from the fin to its surrounding. For the second phase, design phase, which is geometric modeling. In this study, the geometric configuration that will be tested are horizontal cylinder with solid branch fins and different perforation shaped branch fins design. There are 4 designs, which are: the first one is cylinder with solid branch fins heat sink, which its acronym is CSBFHS, and second one, cylinder with triangular perforated branch fins heat sink, which is CTPBFHS. The third one is cylinder with diamond perforated branch fins heat sink, also known as CPDBFHS. And last but not least, cylinder with elliptical perforated branch fins heat sink, which known as CEPBFHS. Next, third phase, which consists of mesh geometry and ANSYS software. For mesh geometry, the mesh is generated which used to guarantee the precision of the simulations. In addition, a grid independence test is required to ensure the independence of the numerical result from the mesh. Next, ANSYS software. ANSYS software is used to build the computational grid and to solve the governing equation. Mesh geometry also must be first created to define the number of mesh elements of the model. After all the parameters have been completed modified, the simulation will start to run until the result converge. The figure below is the example of the result of the simulation. The last one is result and discussion phase, where it is based on the result obtained from the simulation and it will be compared with the experimental data from previous studies that are related in order to achieve the objectives of this study. So I will explain about the expected results of this project. These results have been taken from 3 different journals. So the top of the left side is the numerical model focused on the configurations for the experimental setup and several conditions. In this previous journal, there are several assumptions considered in the flow field and temperature field. So the left side in the bottom, so the graph shows the comparison of experimental data for minimal resistance between the branch fin heatsink and the plate fin heatsink. So to the right side, in this previous study, the figure above indicates that expected result from different study of thermal performance by evaluating the circular perforation at branch fin with 2 different orientation of the fin, which are vertical base horizontal fin and horizontal base vertical fin under laminar natural convection condition. So now we are at preliminary outcome. So in this present study, there are 4 design of heat sinks that need to be examined by simulation. So as we can see at the right side, it shows that where the air flow through the heat sink model. So for mathematical equations, these are the general equations that will be applied to this present study, which are thermal resistance based on fin model, convective heat transfer rate, heat transfer coefficient, Nusselt number, Reynolds number, volumetric hydraulic temperature, and also fanning friction. Next slide. This slide shows the calculation procedure of Nusselt number equation. So the first step is we have to find the total surface area of the heatsink model, and after that we substitute into the coefficient of heat transfer equation, and then we finally find the Nusselt number by substitute the H into the Nusselt number equation. However, this Nusselt number is only valid for CTPB FHS design, as different geometries consist of different equation of Nusselt number. Last but not least is Gantt chart. So this is the project planning for FYP1. So the yellow one indicates to the plan and the green one indicates to the actual plan for FYP1. So the next slide, the project planning for FYP2. Okay, that is all for my proposal presentation for FYP1. Thank you so much for listening.